Hey guys, let's look at lesson 6.3, solving exponential equations, part 2. So today we're going to be looking at the word problem part of solving exponential equations. So I'll get you guys to turn to page 14 in your notes. So page 14 in your yellow booklets. So what you'll notice is that there are two new equations that you've never learned before. One is called the half-life equation, and I'll get you guys to make a correction. Instead of this D at the bottom, it should be an H there. So this comes from your formula sheet where it's y equals a b to the power of x. So this is the original that it starts off being. A is always your y-intercept, your starting amount. So that's what A0 means for both of these. What's your initial amount? So that's your initial starting point. Now a half-life means that the B is going down by a half. So let's say you start off at 10, the next number would have been 5 in the sequence, then 2.5, etc. Let's say you have doubling time, then your B value is 2. So let's say you start off at 2, the next would be 4, then 8, then 16, then 32. So you're doubling the number each time to get to your new value. Then your power is going to be x over however long it takes you to get to half-life. So if you start off at 50, how long does it take you to get to 25, half of 50? Here, D represents how long it's going to take for you to double. How long from your initial amount will it take for you to double? So let's say you start off with 200 of something. Well, when is it going to be 400 of it? So that's what that D and H stand for. So we're going to be using those equations. And for this first example, it tells us that example number 3. When diving underwater, the light decreases as the depth of the diver increases. So as you go deeper in the water, you're going to see less and less light. It gets darker and darker as you go down. On a sunny day off the coast of Vancouver Island, a diving team recorded 100% visibility at the surface, meaning right at the water, they have 100% visibility, but only 25% visibility 10 meters below the surface. The team determined that the visibility for the dive could be modeled by this half-life exponential function. So they're giving us half-life. So that's why our B value has been replaced with 1/2. Okay, so that's our starting amount. What we need to do is fill in all the remaining variables so that we only solve for one item. Okay, so for A, at what depth will the visibility be half the visibility at the surface? What we don't know is our H. Okay, we're missing H when it's going to be half, the depth that you're going to be at half visibility, because that's what H stands for, this right here. H represents the depth in meters where there is half the original visibility. So we should be filling in A of x with a number, we should be filling in x with a number, and A0 with a number. Okay, so they're telling us that initially we have 100% visibility. So that's going to be our A0. We have 100% visibility at the surface because A0 represents the percentage of light at the surface of the water. AX represents the percentage of light at a depth of x meters. We know that we're going to have 25% visibility 10 meters below the water. These guys should always match up, meaning what is the visibility at 10 meters below? They should always go together. So that's what we're going to fill in our variables with. A of x needs to be replaced with 25. A of 0 needs to be replaced with 100 from the above equation. Then we have B is a half, x is replaced with 10, and h is what we're solving for. So this is the hardest part, is filling in your equation. Next, what we're going to do is we're going to graphically solve. To graphically solve, we're going to set the left side of the equation to y1. The right side of the equation is going to be replacing y2. Okay, so this is where we have to go to our graphing calculators and enter these amounts right here. Okay, so in your graphing calculator, you should be entering y1. Go to your y equals. Okay, so press y equals. Enter y1 as 25. And y2 is the right side of your equation, which was 100 bracket 1 divided by 2 to the power of, if you have an older style calculator, put brackets. X was 10 divided by our x. So x is going to represent h. We don't have the variable x to use, so whenever we have an unknown in our graphing calculator, we replace it with x. So even though we have h that we're solving for, we're using an x for our graphing calculator. Next, the window is the second hardest part, is to figure out what your window is to be able to see the intersection right here. Okay, so what we're going to do is go to the window and talk about what each variable stands for. Remember that x represents the depth that you're going to. Okay, so the different depths that you're going to. You cannot have negative depth. So for depth, you're going to go from 0 up to maybe we're going to go up to, let's see, we know that at half, we're going to be at 10 meters below the water. Or sorry, we know that we're going to be 25% visibility at 10 meters below the surface. Okay, so we're going to be less than that when we're going to be half. If we're going to be at 50% visibility, how far are we going to go below the water? It's going to be less than 10. So you only really have to go from 0 to 10 for your x's. You can set it to larger if you really want to. You could have set it from 0 to 20 if you weren't sure. Next, y. Y represents what your initial is and where are you going. So we know that initially we had 100% and we're going to go up to eventually 0%. So percentages, the minimum you're ever going to have for percentages is 0. The maximum is going to be 100 for percentages. Okay, so once we have this window, we're going to graph it. So setting up your window is all about just logic, saying what makes sense for your x, what makes sense for your y. Okay, so this is that 25 value. And we're going to see that the y2 is this, where it's going to intersect. So we're looking for the intersection between, in my case, the blue and the red graph. Okay, so as long as you can see it, you'll be able to find your answer. Okay, so once you graph it, you're going to press second trace. It's going to take you to this menu. You're going to press number 5. You're going to move your cursor until you're as close as possible to the intersection as you can. So that would be awesome if it's right there. And press enter 3 times. Enter, enter, enter. Okay, so your intersection is the x coordinate. Always look at the x coordinate only. Your answer is 5. Okay, so once you find your x value, the intersection, you're going to go and write that, what your window was. So always write down, record what the window you saw your intersection was. So 0 to 10 going up by 1. Your y value was from 0 to 100 because it was percentages going up by 1. Then I press second trace number 5. And then once I press enter 3 times, I got that x equals 5. Therefore, at 5 meters, you will be at 50% visibility. And that's what we just solved for, the half-life. When will we go from 100% to 50% visibility? So it's going to take us when we're 5 meters below the surface. Okay, so now that we have the h, that's always going to be the answer for every single question that follows for this situation. So if h is 5, use that value. So when we plug in the value, when we use our equation now and solve for anything, we're going to solve for and substitute h as 5 now. So this is the new equation that we're going to be using from here on. What is the visibility if you are diving at a depth of 15 meters? Okay, so we already know that initially we still had 100% visibility. Now they're telling us the depth that we're at. Depth represents x, so we're going to replace x with 15. Our h is 5. So all we have to do is solve for a of x, which is one thing. This is one item that we're solving for. This is the same as saying y equals. Okay, so all we have to do is put this into our calculator. So using your calculator, enter all those values that we just recorded, and I'll go back to that if you're not done copying it in. So in your calculator, write 100 bracket 1 divided by 2 times your half-life to the power of 15 divided by 5, which you could have simplified to 3. 15 divided by 5 is 3, or you could just type it in exactly how you see it. Okay, so what we just solved for was 12.5. This is the visibility at 15 meters below the surface. So you have 12.5% visibility at that point. Okay, so we're going to write that down. Okay, so our answer is 12.5. Now, this needs to be written as a percent. So you want to say for word problems, therefore, the visibility at 15 meters below the surface would be 12.5%. So make sure you summarize your answer with a sentence or a therefore statement. Okay, so that's what we just found. And to the nearest tenth means 1 decimal place. So that's what we answered our answer with, 1 decimal place. Okay, so that's our first situation right here. Example number 4, they're giving us the equation now. Mostly everything's filled in except for t and h of t. Again, h of t represents one item. So the length of time that a particular type of blue cheese will keep in a refrigerator can be modeled by the exponential function h of t equals 130 1/2 to the power of t over 43.3. They're telling us that h of t represents the number of hours after the cheese has been put in the fridge. So number of hours in fridge. So that's what h of t is. T, capital T, represents the temperature of the fridge. Temp of fridge. In degrees Celsius. At what temperature was the cheese kept in the fridge if it lasts 85% of the length of time of the usual particular type of cheese to the nearest hundredth? So we want to find out what is 85% of the original initial value. So to find h of t, step 1 is we're going to take 130 and we're going to find out what 85% of this is. So first we have to divide this number by 100 and get 0.85. So we're going to multiply this 130 by 0.85, and that will tell us the length of time for it to, the number of hours it's going to be in that fridge. Okay, so in your calculator, put 130 multiplied by 0.85. You should get that it's going to take 110.5 hours. Okay, so that's how long it's going to be in the fridge. Next, we're going to substitute that for h of t, because our final goal is to find capital T, the temperature that the cheese should be kept at in the fridge. So we're going to replace h of t with 110.5. Everything else stays the same. And then this is where I put the left side of the equation into y1 and the right side of the equation into y2 in my calculator. Okay, so I'll just leave that for a second longer if you need to write that down. Okay, so we want to put the left side of the equation was 110.5. The right side of the equation was 130 times by 1 divided by 2 to the power of t can be represented by x, and you can put brackets if you have an older style calculator, divided by 43.3. So if you have a newer style calculator, you don't need brackets. Older style, you do need brackets around your exponent. Okay, so next we have to figure out the window. X represents temperature. Well, Celsius, when we're talking about fridges, we can be in negative and positive degrees, right? So let's go from negative 10 degrees Celsius, because that's going to be our temperature. Let's say we have negative 10 in our fridge, up to a fridge could be warm as well. So we can set our fridge to a hot temperature, let's say 30 degrees Celsius, even though that's probably not going to be close to that because that would melt the cheese, but we're just making sure that we are able to see an intersection. Okay, so that's X represents our temperature of our fridge, versus Y represents how many hours you're going to keep that cheese in the fridge. Well, we know that we're going to keep it in the fridge for 110.5 hours. So as long as we can see 110.5, that's all we need. So we're going to go from 0 to something larger than 110.5. So maybe up to 200 if you wanted to. Okay, so this is my window here. Once I have my window, graph it. So there's my 110.5 being graphed. Okay, and my intersection is being formed. So once you have the intersection visible, by setting your window properly, press second trace number 5. Move your cursor as close as possible to the intersection, which mine's already there. Press enter 3 times. Okay, the x coordinate is your answer. So you should be getting, it says to the nearest hundredth. The answer is 10.15, and that would be in degrees Celsius. Okay, so once you have your window set, remember, write it down. So I'm going from negative 10 to 30 degrees, going up by 1. And for Y, I set it from 0 to 200, going up by 1. Then I press second trace number 5, and I found that the answer was 10.15 degrees Celsius. So I want to say that therefore the temperature is 10.15 degrees Celsius, okay? So make sure you show your steps. This is how you show your steps. Show your window, show what buttons you're pressing, and then show your final answer. That's how you show your work when it comes to a graphical solution. Okay, so final answer is 10.15 degrees Celsius. Always the x coordinate is what you're looking at. Now with the same situation, if you wanted the cheese to keep for 5 days, at what temperature should the refrigerator be set? So there, you're looking for the same kind of thing. You're looking for still the temperature, but they're giving us that the temperature, or the number of hours that they're keeping it for, h of t, is 5 days. Now the problem is that 130, when I use 130 in my original question, in my original equation, this was my original. This was in hours. You cannot have hours and you cannot have days in the same equation. You have to be consistent with your units. So what you want to do is you need to convert from days to hours. So we know that there are 24 hours in 1 day. Now the days will cross each other off, leaving you with 5 multiplied by 24. So 5 multiplied by 24 is 120 hours. That's how many hours there are in 5 days. So that's what you're going to be using for your equation. You're going to set your y1 to 120, and you're going to set your y2 to the right side of the equation, 130, 1/2 to the power of t over 43.3. Okay, so in your graphing calculator, you want to change your window. So your window can still be the same as original. As originally we had from negative 10 degrees Celsius to positive 30 as our min to max. Our y would still work if we kept it the same. So don't change your window from the previous question. The only thing we have to change is our y1. Okay, so go to your y equals button. Instead of 110.5, put 120. Okay, so set y1 to 120 and graph it because the window is the same as our previous question. Okay, so we can see that there's an intersection between my blue and my red. So now it's just about finding that intersection, and the buttons that I press are always consistent. Press second trace, number 5. Press enter, enter, enter. Okay, so my intersection should be 5. So what that stands for is the temperature you should be setting your fridge to. So we just found by pressing second trace, number 5, pressing enter 3 times, we found that x equals 5, and to the nearest tenth we have to put 0.0. So that's to the nearest tenth is 1 decimal point. So therefore, temperature should be set to 5.0 degrees Celsius. Okay, so make sure you have that summary statement at the very end. Okay, so what you want to do right now is you want to practice these questions in your homework. This is the continuation of your day 2 homework. So it's page 363 to 365, number 10, 11, 13, and 15. Those are the word problems. Make sure that you're checking your work, okay? So make sure that if you're done those questions that you go back and you finish your day 1 completely and your day 2 homework to finish off for Tuesday.